Hi everyone, this is Purnima Mahalingam and you are watching video lecture series on field theory. In last class, we are discussed about Cartesian coordinate system and today we are going to discuss about cylindrical coordinate system. Come, let's go to the video. So here the cylindrical coordinate system is represented by R, phi, Q, and we have discussed. So dr is an informatory displacement along R. R t theta is along with the phi, and dz is along z direction. We have already discussed the dx is already in parallel to z axis. And a volume elementary is given by dv. dv is the difference in volume. It is difference in volume. It is represented by dr, difference in radius r, and d phi. D phi is an angle with an angle phi, and dz that is with an angle parallel to z axis. And limitations of integration of r theta phi's are, so that is r is the range between 0 to infinity. R is the range between the 0 to infinity, and z is also 0 to infinity, and phi is 0 to pi. Phi is 0 to pi. Shows that the volume of a cylindrical of radius r and a height h, that is pi r square h. So here the pi is assumes angles. Okay. The next is volume of integral of a radius r. Volume of an integral of a radius r. Volume of integral of a radius r and height. Here the volume v is a so change in volume. The change in volume, that is volume integral. What is a volume integral? Is change in volume is into r into dr, d phi into dz. So here how we can write this change in volume, that is triple integral, that is 0 to radius r into dr, 0 to 2 pi, that pi is a d phi, and for h for z, height 0 to h. So that is pi r square h. So the volume v equal to pi r square h. So try the surface area of the same time we can try for the surface area, that is 2 pi r h. That is surface area is equal to 2 pi r h. Okay, the base area of the cylinder discus, the base area of the cylindrical discus pi r square, pi r square. Okay, here comes next is differential quantities. Then what is the differential quantities? What are the quantities we have? That is difference in quantity is length element, that is difference in length, and difference in area, and difference in volume. Here we can say difference in areas, a difference in area of x-axis, difference in area of x-axis, y-axis, and z-axis. Instead of x, y, and z, we are having r, phi, and z. We have difference value, and the total volume, difference in volume, and difference in length. So total difference in the a vector into dr plus a phi vector into r d phi, and a z vector into a dz. So different, this is the length element, difference in length, difference in area, and this is difference in volumeter. So the limitation of integration are r pi phi, whereas the limitation is r is from 0 to infinity, z is also 0 to infinity, 0 to 2 pi. Okay, here comes next is spherical coordinate system. Here comes spherical coordinate system. Here the spherical coordinate system, we have a spherical in that spherical we have a radius, we have taking some point, we have taking some particular point. So we have a radius, that point with an angle theta, the radii and angle phi. So for radius of phi on a point theta, or a point was a theta difference from the x-axis or y-axis or z-axis. And we have a radius with an angle phi. Okay. Here we can see the with an angle phi, radius with an angle pi. This is theta, and we have a point. The point is represented by r theta and phi. That point is represented by r theta and phi, and the dr is the inflammatory displacement, and along r and d phi is along theta, and r sine d phi is along flux phi directions. The volume element is given by dv, that is dr r d theta r sine theta d phi. The limitation of integration, that is what is the limitation is r phi theta phi, that is with an angle, r is with an angle 0 to infinity, phi with an angle 0 to pi, and flux phi equal to 0 to 2 pi. That shows the volume of a radius r is equal to 4 by pi r cube. So where theta is a zenith angle and phi is a azimuth angle, and starts from plus z to minus. It starts from plus z to minus z. That is theta. And azimuth angle is from plus x to plus x axis to on the lines of xy plane, plus axis to line of xy plane, that is flux phi. Okay. There's a volume of sphere, sphere angle of radius r, that is v equal to d phi dv, that is volume r square dr sine theta d phi. We are taking the volume integral of 0 to r, 0 to phi, and 0 to 2 phi, and finally we're getting 4 by r. The volume v is equal to 4 by r, 4 by r. 4 by 3 pi r square. That is surface area of the sphere is 4 pi r. Okay. So this is what an volume integral of a cylindrical system and sphere system. So we can continue this lecture in next video. Thank you so much.